You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hey everyone, welcome to the Wi-Fi Ninjas podcast. Matt and Mac here, but today we are also joined by Brian. Brian, how are you, and would you like to introduce yourself, please?
I'm doing well. I'm Brian White, Director of Systems Engineering at Celona. Had a long career in Wi-Fi. Started doing Wi-Fi back in '96 or so, which was crazy. Before it was called Wi-Fi. And then started working on enterprise 802.11 networks as that standard was ratified in '98 or so, '99. Started to work on some very, very large networks, I think 3,000 or so APs back in '99, 2000. And then took a hiatus a little bit, and then joined Aruba as one of the first SEs in 2004, first group of SEs anyway. Spent about 11 years there, peeled off, did some cloud-based Wi-Fi, helped relaunch a company into what became Mojo Networks. And then about a year ago, joined some ex-friends and colleagues over here at Celona.
Nice, quite a esteemed career in Wi-Fi then.
Been fun.
Quite a history, man. Like 20-something years in Wi-Fi, 1997.
I remember sitting in a room and we were all trying to figure out a WEP key rotation server and trying to figure out how that would work because everybody was worried about losing the PCMCI adapter in the side of the computer because the WEP key was burned in. And one of the guys in the room was basically like, well, what about this new thing, 802.1x? We're working on it with Windows for wired authentication. Let's turn it into wireless authentication. And there you go. That ended up happening, and off we go, right?
Must have been quite a journey back then. It's like when it wasn't like too standardized back then. No one was using it, doing it.
Right.
They were blank pretty much, and yeah, you couldn't Google everything. 25.
Yeah, sure.
Yeah.
We actually made our own power over Ethernet solution. A colleague that I worked with, he kind of came up with this design that took higher voltage AC and used transformers to put it down to low voltage, 48 volts, 36 volts, whatever it was. And then you could run low voltage cable through the building, but then it would step it back up, a transformer on the other end. And there was a 110, jack in the, a 110 volt jack in the ceiling where you'd plug the AC adapter for the access point into. It was predated PoE, obviously, right? And those kind of came up with our own way. Anyway. Yeah, enough of that. It's still fun.
So this is our third part to our series of podcasts that we've done with Celona. So thank you very much for joining us today. The last two have been great. It's been, I think, really nice for the Wi-Fi guys to hear about, some of the offerings of private LTE and CBRS. But I think one of the biggest questions on the lips of all of the Wi-Fi guys is, are we still going to have jobs in Wi-Fi now, with all this private LTE and CBRS come in? So what do you think the role of private cellular is going to be, especially 5G and CBRS and coexisting with Wi-Fi? Are we safe? Are we gonna need to start finding some new jobs, or what do you think, Brian?
I don't think Wi-Fi is going anywhere. I think Wi-Fi has its definite use cases. I think that just normal enterprise computing, laptop access, you're hitting websites, you're hitting email. There's really little true SLA that goes along with that behavior within a user community. I think where the private cellular networking is taking off and the interest is really there is when that wireless connectivity needs to be highly predictable, reliable, and there are certain use cases that really benefit from the increased receive sensitivity of a cellular radio. There's challenging environments, warehouses, ports, especially outdoor where you need great range. The power outputs of category B CBRS, which is like the higher power outdoor units, are up to 50 watts. So you think about what you can cover outdoors with 50 watts, and Wi-Fi is still down on the 1 watt limit there on the outdoors. So I think there are certain use cases where private cellular makes a lot of sense. And I think that some things will move from Wi-Fi to private cellular as they have those requirements. But Wi-Fi is still perfectly suited for normal enterprise laptop computing, email, web browsing, your normal thing. High bandwidth as well, right? Wi-Fi has very high bandwidth considering how easy it is to deploy wireless access points, Wi-Fi access points within a facility. And there's no channel coordination, which is both a benefit and a disadvantage, right? And it allows me to put in Wi-Fi wherever I need it without any consideration, about anything else going on in there, which again is a good and bad thing. So anyway, Wi-Fi is not going anyway.
Okay,
Okay,
good. So
that's
I
a good
can
answer.
I
So
can
you said
stop.
that the capacity-wise, it's easier with Wi-Fi. Does that mean that Wi-Fi is still faster than private cellular?
So it's definitely faster than private LTE. There are operation modes in private 5G where it could be comparable. And then in private 5G, the latency gets very low. But for right now, with the private systems using LTE, Wi-Fi is certainly faster.
Okay.
Okay, good. So I can stop Googling now for a job application to Celona for private CBRS engineer. That makes me feel a little bit better.
We'll say the next year.
Safe for another year. Okay, good, good. So you mentioned there's some specific use cases then that you believe that private LTE and CBRS would be better suited for. Maybe can we just dive a little bit deeper into what you think those specific use cases are?
Sure, I'll highlight a couple of them. First off, I would say warehousing. Anywhere there is kind of a challenging environment with mobility within a warehouse or a manufacturing facility. I think having those automated guided vehicles or AGVs um, controlled via Wi-Fi, which happens quite a lot these days. But what the pain that they're feeling is that the reliability of the handover between access point to access point can sometimes be compromised by the speed at which the AGV is moving, but also could be impacted by environmental concerns such as what's in the racks today, and did I go down this path that has very kind of marginal Wi-Fi coverage, and then what happens to that device. I think one of the key things, if you think about that, is that it's actually within Wi-Fi, it's the Wi-Fi device that's actually making the decision. Which access point should I associate to? When should I roam or hand over between AP1 to AP2, and which AP am I going to hand over to, as well as when I should transmit. Like all of those things are handled by the infrastructure within cellular. The infrastructure says you're going to associate to this access point. You're going to hand over from this access point to this other access point at this specific time. I'm going to tell you when to transmit. And what that does is it drives that link layer reliability a bit higher than what Wi-Fi can do, just basic architectural reasons. And there are certain applications, such as the AGVs, where that link layer reliability is very advantageous. And people have been trying to do this with Wi-Fi for years. And how they're able to do it, if they're able to do it at all, is they're kind of over-engineering the Wi-Fi network to meet those needs. And sometimes that can be very hard and very tough in those environments. Another example quickly is like healthcare communications. Wi-Fi networks for years have been used to handle clinical communication systems between nurses, doctors, anyone else in the facility. And a lot of those voice devices require neg 65 or greater signal strength from the Wi-Fi network. And sometimes that's very, very hard to get across a ubiquitous floor plan. Like there's many places where you can, but there's always going to be places like, oh, well, it has trouble in this corner and over in this section over here. And cellular has the ability, because of the low receive sensitivity or the high receive sensitivity of the radios on either side, to kind of fill in a lot of that area that Wi-Fi couldn't fill in.
So are you seeing more and more devices that support the CBRS, like frequency band, and lots more devices being shipped that support this? I know latest iPhones do, but are there any other players in the market that kind of jumping ship to the game?
Yeah, for sure. Yeah, all the Apple products since the Apple iPhone 11 and iPad Pros that were released at that same time have supported it. and they continue to. They're very bullish on CBRS with their device support.
Do you think
Google
we're likely to
Pixel.
do you think we're likely to see it in anything other than mobile devices? So not just mobile phones, but like
Yeah.
in voice
Yeah.
handsets or laptops and things like that. Do you think?
Right. So like Google Pixel 3, 4, there's a lot of Samsung tablets and phones, but as well, the laptop manufacturers have jumped on as well. Lenovo kind of released one at the end of last year. HP has announced a whole family of laptops that support cellular with specifically the CBRS, which I find kind of funny because in like the 2005 to 2013 kind of range, almost every laptop I had, and I had Lenovo's, exclusively during that time, every single one of them had a SIM slot in the bottom with a 3G wide area network modem in there. And I used mine all the time. It was great. And then somehow, some way, they kind of stopped having this. So now they're getting back to where they were about 10 years ago with adding these radios again to the laptops. So you're starting to see it. And the CBRS Alliance, which was renamed the OnGo Alliance, maintains a master list of everything that's been certified. So it's nice to go in there into that list every a month or two, and you kind of see all of the devices that have come in with this support.
So that's nice that we're starting to see lots more clients supporting CBRS. If I had a hospital right now where I've got a full Wi-Fi deployment, so I've got my access points deployed everywhere, I've got my Wi-Fi coverage, but then I start buying these client devices that support CBRS. From like a ecosystem perspective, would we need to overlay an additional system, like install additional CBRS access points? Do you think in the future there will be types of model devices that support Wi-Fi radios as well as CBRS radios, so you don't need to have maybe two systems? Maybe you can just buy an all-in-one. Like, how do you foresee the future?
Yeah, so currently, of course, it's an augmentation of the Wi-Fi network. So you would actually deploy your CBRS-based cellular network, um, kind of as an overlay, I guess. I don't really like the term there, but as a separate system interspersed within all of the Wi-Fi APs, you would have your cellular access points, controlled by a different system typically. The ratio of the number of Wi-Fi access points to the number of cellular access points required for a given space, it does vary. Like with any wireless technology, it varies with what's in that building, what's the construction, that sort of thing. But we're kind of averaging out, anywhere from, for every 3 to 6 Wi-Fi access points, you need one private cellular AP. Of course, it does depend. So right now, it's kind of an augmented system, or a system that's there on the side. To your question about will they be combined into one device, the challenge that I think that's a debate within the industry. The challenge that I have in my head, which is back to that ratio, for every Wi-Fi AP, every 3, 4, 5, 6 Wi-Fi APs, there's one private cellular AP. That means that I don't need every one of those devices to have a cellular radio in it. And therefore, from a cost and a manageability and all sorts of reasons, why would I want to co-locate them in every space? So I think that jury is out. I think people may come up with some combined units, but whether or not every single point within the facility is a Wi-Fi / private cellular device, maybe you turn off the cellular radio, but then that's of course a waste of cost. So anyway, yeah.
And just two things there about what you've mentioned earlier. You mentioned about the use case for the AGVs. I didn't know what they are until I listened to Clear to Send podcast about the automated vehicles design in Wi-Fi for like some manufacturing plant, which was amazing.
Yeah.
What does it stand for?
Automated guided vehicle. Sorry, I can't talk. Automated guided vehicles. Is that what you're asking?
Yes, I am. So what you were saying few minutes ago is that the private cellular will be probably a better fit for this kind of devices because it's less complex when it comes to over designing a network for what these devices require. You won't need to have hundreds of APs. Maybe you will just need to have a few dozens of cellular private cellular radios around. and they want me to roam that aggressively and massively and very often, this kind of stuff. So that's a very good point. I wanted to come back to that. And also another very extremely valid point was about all the devices being managed from the infrastructure side. So infrastructure makes all the decisions in the cellular world. Of course, in private cellular is the same thing, versus in Wi-Fi, where all the decisions pretty much typically are being made by the devices. So I just wanted to highlight that. And by saying it, let me just ask you this question.
Mhm.
You don't believe in OFDMA in Wi-Fi 6? It's a scheduling done by the infrastructure.
Yeah, of course. I think we've all, those of us who have done Wi-Fi for a long time have long had these promises of certain features or certain things that are going to be added in, and we're adding this feature and they're adding this feature. But one advantage and disadvantage of Wi-Fi, one advantage is it's backwards compatible with Wi-Fi all the way back to 802.11b, right? Even my newest AX AP can support, that 2.4 gigahertz 802.11b client. And that's a benefit, but it's also a lot of the newer features that we're talking about here that have come in across over the years have had incomplete or inconsistent implementations. So some clients support it, some clients don't. Well, that's optional, that's required. And what you get is, yes, I may have some of these more advanced things, but not all my clients can support it. If not all my clients can support it, can I even enable it, right? I think that's one of the challenges on the Wi-Fi side is there are these little peppers of advanced features that are sprinkled into the product over the years, and a lot of times you're just like, yeah, I'm not enabling that.
Yeah, that's what we do. Like one of the first things that we do while deploying Wi-Fi 6 is to probably sometimes disable Wi-Fi 6 features because
right,
yeah.
right.
Okay.
So and I think on the cellular side, having the client really follow instructions from the infrastructure, all of those famous issues that we deal with on Wi-Fi, sticky client, and all that stuff kind of goes away because all of that is our wireless clients making poor decisions. Well, in cellular, clients don't make decisions. So
Yeah, but that would be quite challenging for guys like Apple that employ hundreds of people working on the Green Diamond algorithms, thinking about which next radio BSSAD to associate to, what to base these decisions on, and etc. But I agree, it makes sense for the infrastructure to have more say in decision making about connecting to different radios.
right.
However, from the client's perspective, it's like infrastructure. It doesn't see everything that the client does, right? So the environment is different on both ends. So probably both approaches, they kind of make sense. And also Wi-Fi devices, they tend to be, I don't know, cheaper maybe because they don't have to be as complicated and have like a firmware that is so sophisticated. And battery operation, what do you say about cellular versus Wi-Fi? Which devices are more robust?
A lot of people I talk to, they're very curious about CBRS. They're concerned that it's a new technology, and the thing about it is, it's a very mature technology. LTE has been around about 10 years, and what's new is the fact that this technology is now available for enterprises to use. So they're learning about a lot of this technology for typically the very first time, and everyone has experience with cell phones. But how do I take that experience and kind of map it into what I'm doing within the enterprise? And some people get hung up on, oh, it's a cell phone, that means it's voice, that means it's, what about SIMs, what about carriers? And effectively, we just try to bring them back to, this is just an alternative data network that happens to use this technology for your enterprise needs. As far as battery life goes, LTE is very efficient with battery life. Wi-Fi can be as well. Obviously, there are tweaks that can be used to increase the battery life or maintain the battery life of those clients. But cellular has all that stuff in it as well. I mean, battery life on a cellular device is extremely important. So.
Okay, so how does it really work? Like when you have, I don't know, like hundreds of milliwatts maybe in Wi-Fi, and then you have more power. What was the wattage that you can use in cellular, like up to 100 watts from the radio's perspective, you said before?
It
50.
was 50. But what ends up happening is there are two different categories of what the CBRS Alliance terms as CBSDs, which are CBRS devices, base stations, access points, eNode Bs. And there are two classes of those. One is called Category A, and Category A is typically indoor. They can be used outdoor in certain scenarios as well, depending on whether you have weatherproofing or not. But they are limited to 30 dBm of transmit power. And then the Category B devices are always outdoor, at least within the CBRS world in the FCC in the United States. They're always outdoor, and they have a max EIRP of 47 dBm, which is 50 watts. Now that's per 10 megahertz channel. Obviously, if you're doubling, you get a little bit of channel aggregation increase there, but 47 dBm is the max for Category B, and 30 dBm is max for Category A.
Okay, yeah, these are quite high values. So the clients, obviously, they're not as powerful as your radios. So how does it work? Does the radios, do they use like more directional antennas to have like a better sensitivity while receiving the information back from the not so powerful clients?
Yeah, so a lot of CBRS clients are 23 dBm max, and there are some clients that are higher power that can go up to 30 dBm. I think there may be even some greater than 30 dBm clients. These are more CPE devices with directional antennas, like if you're really trying to get high range and everything. But from your typical handheld, yeah, you certainly have that max power. You have a lower gain antenna, that sort of thing. But with these cellular networks or these cellular radios, the receive sensitivity of those radios and those antenna structures are very high, much higher than Wi-Fi. Like I said earlier, Wi-Fi, you're looking at neg 67 dBm, that sort of thing. Here we've gotten connected in some of our outdoor tests at neg 115, neg 120, neg 125, right? So the key is that with Wi-Fi, as you're moving away from the cell, your effective data rate kind of comes it lowers in a linear fashion. It's kind of like this steep hill that goes all the way down to basically nothing, right? And the thing with cellular technology is it's more of a plateau. As you get further and further away, you're still maintaining usable bandwidth really very far to the edge of the cell, even to where you may only be getting, a couple 3 megabits down and 500K up, but your connection is still usable. And that's what's different between this technology and Wi-Fi, is that I can use this technology, or I can use this network link way, very far to the end of the cell, whereas Wi-Fi would start kind of being unusable much sooner. So it's really a combination of all of those. And I get that question a lot from Wi-Fi people, that whole, what the client can transmit versus what the access point can transmit. It's made up a bit with, of course, the antenna and the receive sensitivity of the radios.
But that's it. That's the receive sensitivity. So we can get away with omnidirectional private cellular radios in a warehouse environment, for example, and still cover quite a lot, where our handheld scanners or whatever AGVs, they will be able to reach back to the radio because of higher receiving sensitivity. So that's it.
That's correct. And a lot of those devices, those are not high bandwidth devices. So this is another comparison between Wi-Fi and cellular, at least right now in the LTE world, because LTE world the LTE technology is really only good for about 130 megabits down and about 27 megabits up. Right? You think about that compared to Wi-Fi 6, and you're in the multiple hundreds of megabits per second in your typical enterprise deployment, bidirectional. And
there is a question if you really need it, like we've covered it with Matt recently in one of our videos for the enterprise design, where we've concluded that honestly, like even on this call now with audio, video, screen sharing sometimes, I'm not exceeding anything like 2 megs really in either direction. So I guess a private cellular is fast enough for most applications. So when it comes to the speed, I think most of the enterprises will be 100% satisfied with that, because you don't need more even for high quality streaming of Netflix or whatever. It's fine. 4 megs or 8 megs is all you need to get this 4K stream. It's the reality. So you don't need anything faster. But how about the number of clients associated to the radio? In Wi-Fi, we don't want to exceed like 20 or 30% of airtime utilization because of the contention and the game that devices have to play to access the medium. We don't have this problem in cellular, right? Because it's scheduled from the access point perspective. But how many devices can it schedule the transmissions for?
Yeah, so that does vary with equipment. For our indoor access point, it is 64 clients per sector or per carrier per radio. So that the access point has 2 radios in it, so it's really 64 per. But what's different in the Wi-Fi world is that 64 that I speak about are clients that are simultaneously communicating, and that 64 is the transmission queue, the scheduler, right? But many more clients can be attached in the idle state, and the access point can move clients in and out of that scheduler and put them in and out of the idle state just very quickly, right? So there's no real hard number of, like in Wi-Fi, you have, the radio can support a maximum of 256 associations, and then the 257th is just, not taken at all.
I would be quite nervous if I saw 256 associations on my radio.
Yeah, I'm just talking about the chipset limit, right? Which is usually that. Certainly, we design for much lower, and you can artificially cap by doing the resource allocation with the with .11. But in this particular case, from the LTE access points especially, or considering ours, it's 64 per sector, so 128. And you think about that, the fact that that's not a hard number because the units moving devices in and out of the idle state, it's pretty effective.
There we go, mystery solved. So, and it really doesn't matter if the devices they do like a voice only or downloading data or streaming Netflix, of course, just for work purposes, it will still work for these devices. If you have, like, let's say 64 corporate devices doing like a heavy-ish load.
Well, see, and the other thing though is these access points are 2 radios in them, so you really have double that capacity. The best way in the Wi-Fi world to think about this is the proliferation of dual 5 gig APs, right? Like 2 or 3 years ago, people just were going crazy over dual 5 gigahertz because you were basically spreading that capacity across 2 different radios on 2 different channels. Well, that's how these private LTE access points work anyway. So I have that additional capacity. The other thing is, if I do need capacity, a lot of the statements I've been making in this discussion really have to do with coverage models, right? Less number of APs for a given area and that sort of thing. But if you need additional capacity, you can just add more access points. And usually in the Wi-Fi world, that's somewhat problematic because I don't have enough channels, or whatever the reason is. In the cellular world, I may get to a point where my channel reuse has gotten to the point where I need APs in relative closeness to each other, but on the same channels. And remember, it's that scheduler that's scheduling all of these transmissions. And so the system can be more intelligent about channel reuse from the standpoint of it can make sure that devices really aren't stepping on each other and that sort of thing. I think some of the numbers, and I'm far from the world's most, the biggest LTE expert in the world, but my understanding is in some cases you can have adjacent APs, servicing clients and adding to that capacity, but really only losing maybe 5 to 10% of the overall, kind of efficiency because of the scheduler.
The same frequency.
Yeah, using the same frequency. Yeah. So. Channel reuse is really huge in cellular. If you think about some of the carriers, the operators that, Vodafone in the UK, or, T-Mobile or AT&T here in the United States, They only have so much spectrum. It's surprising how much spectrum that they have, and this is countrywide. They may only have 125 megahertz or 180 megahertz or 230 megahertz or something crazy like that, and they're covering the whole country. So channel reuse is very, very important, and in cases where there's adjacency, that efficiency of the LTE system and the 5G system means that the channel reuse problem is much more managed than it is in the Wi-Fi world.
And that's good to hear, mate. And that's between the stations that they might belong to different organizations, so that's fine. And within your own station, that's what we've discussed in the previous podcast. I think that was like the QoS of the private cellular that you call the micro slicing.
So just to be clear, it's within the same system that scheduling comes in. So differing systems, they wouldn't be on the same scheduler and that sort of thing. So where the help there comes in is at least in the United States with the Spectrum Access Service, that frequency coordination system, does its best to prevent neighbors from stepping on each other. Now, this gets into a little kind of strangeness, is that currently the SAS is set up to protect Tier 1 and Tier 2 from Tier 3, which is incumbents, which is naval radar. That's Tier 1. Tier 2 is PAL, Priority Access License, and then everyone else slots into GAA. Right now, the SAS is really set up to protect PAL and incumbents from GAA users, but GAA users, they have no protection from themselves. So there is some work in the CBRS Alliance, the OnGo Alliance, it was renamed to OnGo, to have some coexistence with regards to different GAA operators within an area, and that the SAS can coordinate frequency between them. That's still a little bit of work in progress, but to your point about the scheduler, that's really within the same system.
Okay, that answers my question, I believe. And you also mention quite frequently US this, US that, but we are not in the US, so we don't care. I'm joking, of course we do, but where does a private cellular operate outside of the US? Can I have it at home now?
That is a fantastic question.
I'm glad I asked.
Yeah, in fact, the term CBRS is not a technology, it's not a protocol, it's simply the name given by the United States FCC to the frequency range 3.55 to 3.7 gigahertz. That's it. That's all CBRS means. Everything else, it's just that it's LTE operating within that frequency space. International. So when we talk CBRS, a lot of times I'm very specifically talking about within the United States because of that name. Within, in a global perspective, the UK has been making strong progress toward opening up some spectrum for private cellular use. Germany has as well. There are some private networks, some test private networks operating in both countries, from what I understand. Japan is another one that's fairly far down that path. But there is a bit of a difference in operating. So some of that frequency coordination system, that Tier 1, Tier 2, Tier 3, the SAS, that is unique to the United States deployment of private cellular. The frequency allocation may be different in different countries. Obviously, it's different frequencies in different countries as well. I think Germany is like 3.7 gigahertz, that sort of thing. And theirs is a manual application. You actually manually apply for those channels, and then you get granted the use of those channels. And so they're doing what the SAS is doing dynamically and automatically, but they're doing it manually, which it's kind of two different ways to the same end, which is preventing people from just stepping on each other with, Wi-Fi being completely unlicensed. We've all dealt with networks that are neighboring to ours that are using all the same channels, and
especially in Wi-Fi, it's a problem, like pretty much number one problem in big cities, especially on 2.4.
Sure.
Okay, so before we jump to another thing on our list, which is the cloud operation, I think it's a very important thing to quickly recap what is really required to be owned by an enterprise in order to use private cellular. What devices, what servers, and what do we really need to get going?
So there are various architectures that are sold by various vendors. I will speak specifically to the Celona requirements. So it's not necessarily a requirement for private cellular in general, but what Celona requires.
Does that mean you have a competition? I didn't know.
Yeah, as far as competition goes, there are some other players in the private cellular space. None of them are doing it quite like we're doing it at Celona. Some of them are taking more operator type architectural approaches and trying to adapt that down into the enterprise. Or they're saying, I'm only selling this part of the overall solution, and you have to get these other pieces of the overall solution through other vendors. Where Celona is unique in the market is that we are end to end. We're selling the entire system as a package. And as an enterprise, they are typically used to purchasing systems like that, like Wi-Fi controller systems. And maybe the one exception is, what authentication system are they going to use? Maybe that's a different vendor or a different system. But as far as the operation of the access points and the controller and the configuration and the management, usually that is all one system. And so that is very much how Celona is attacking the enterprise market, is selling private cellular, but in a way that is very comfortable and normal for an enterprise IT organization to purchase and deploy.
Yeah, so it's just like an access point and a server with an orchestrator and everything on it, and you just don't care about that; it just works.
So those three things you said, the server and the orchestrator. So the orchestrator is our management system. It happens to live in the cloud. It's a cloud-based management system. So in that case, it's similar to some of the other enterprise cloud or cloud-based enterprise networking vendors. Our server, which is really running our cellular evolved packet core, is comparable to what a wireless LAN controller would be. That's part of the data path. That's actually where I'm taking wireless traffic and putting it out onto VLANs and that sort of thing. And then you have the access points. And all three of those things are incorporated in the Celona solution for enterprises to deploy. They're used to deploying systems like that. So now that Celona Edge, which is that server, that controller that you mentioned, this kind of gets into the first part of your question, which is deployment of that system within the enterprise. And there's multiple ways to do that. We actually can sell it as an appliance for those IT organizations, these networking groups that don't like to talk to the server people, which happens surprisingly often, make it easy to deploy. The other way is you can spin it up in your own corporate VM. So that gives you an interesting bit of flexibility about where you want to put resources and where you want your data path to end. Do you want all traffic to break out locally there at your site? Do you want it to go into a data center? Do you want to break it out in different directions? You have the freedom to do any one of those. And then, of course, all of that is managed via the cloud-based orchestrator.
Okay, so let's talk about this cloud-based orchestrator. Let's spend there a second or a minute or 5 minutes, maybe.
Sure.
So orchestration from the cloud in context of the enterprise wireless, what is it?
Yeah, so I kind of think about this in a funny way, and the term orchestration came around a few years ago when talking about cloud services, and you're really kind of orchestrating the installation of those services across different hosts, maybe globally, right? So that whole orchestration term kind of got adapted into the network side, where you were deploying masses of devices and synchronizing the configuration with maybe a centralized management system and so on. We've all been doing this in networking, specifically Wi-Fi, since 2003, because Wi-Fi controllers came around and I could just throw APs out anywhere and they would inherit their configuration. And maybe I was doing mass centralized configuration. To a certain degree, you could say that was orchestration, right? So I think now, as modern cloud orchestration techniques have come into play, you're effectively doing the same thing. You're rolling out configurations in mass across multiple devices, across large swaths of geography. But to simplify it, really, it's you're configuring the network. I think the other piece with orchestration, at least specific to the Celona concept, is where does that Celona edge, where does that quote server live? And that's another piece of the orchestration, because I am orchestrating or deploying those network services in various locations. I may be deploying them in the local branch or the central data center or the main campus or across multiple campuses. And I have the ability to orchestrate the installation of those services from the cloud, from a centralized management system. And in our case, it's cloud-based.
And so you mentioned that the new cases, all of the new use cases that you have are kind of like enabled by this cloud-based orchestration. There's also something else I think I heard you mention about the edgeless enterprise. How far away from this architecture actually becoming a reality?
Yeah, it's interesting. There are parts of it that are very close. And with regards to from our Celona Edge, which is the cellular evolved packet core in the Wi-Fi world, you can think of that as the controller. The way we can spin up those services as the network grows or as the network has differing network requirements, where I want my traffic to egress, how many resources I need in location A versus B versus C. I have the ability to spin up those services wherever I need them. And they could be, again, local data center, could be corporate space. We're getting into situations where maybe they can be deployed on cloud-based mobile edge computing systems like what Azure and AWS offer, local offices. So we're getting to the architecture is certainly there, and I think in practice we will get to the point where we can just spin those services up wherever they're needed, however they're needed. And that's really what this edgeless enterprise idea was all about. And so you could have your entire cellular network, but that service is being run by resources in various places, in various methods of deployment.
Okay, so like in my head, in Wi-Fi, when you have a wireless LAN controller, it does what it's called. It's like it controls the network. So it pushes down like the configuration and stuff, but then all the devices that they're making their own decisions about where to jump to, and then the access points, they're doing some intelligence about the authentication. Maybe they will talk back to the radio server, maybe not. How about the latency requirements for the orchestrator in the cloud? Like if I put Celona Edge in the cloud and I want to be able to schedule very sensitive voice conversations with very, very little latency, how would that work? How would the access point, the private cellular access point, know how to schedule it so quickly so when I have my voice packets, I will be able to put them in as fast as I need?
So typically, the Celona Edge, which is of course the evolved packet core, not the management system, usually that's running on the customer premises somewhere anyway. I mean, it theoretically could run in the cloud, assuming that your destination for all of that wireless traffic is actually the internet. That kind of makes sense, right? That would be the same thing as me putting my wireless LAN controller in some colo somewhere and just uplinking to the internet. But the vast majority, if not all of our deployments, that Celona Edge is not living in the cloud. It actually lives on the customer prem, because by definition, this being a private network, usually there's a reason they want this network to stay private, is data sovereignty. They want all traffic to stay local, that sort of thing. So that's usually how that's done. And as far as latency goes, LTE has certain typically set latency numbers with it. 5G takes those numbers and makes them a lot lower. So yeah, it's really usually an on-prem device.
Yeah, that makes sense. So we have an on-prem device that gives you the decision-making intelligence that makes it all fast and reliable. And then you have the software that lives in the cloud that is used to configure everything, overlook everything.
Correct. Configure and monitor and manage as well. That's the API interface to customers or managed service providers that want to pull information from the system. They can do that via the cloud-based management system. In Celona's case, the Celona Orchestrator, via RESTful API. So
that sounds like a very familiar, to be honest, with what we do in Wi-Fi when it comes to architectures. But I like the flexibility that you can put different boxes in different places to have traffic switched how you want it, really.
Right.
either channel to switch locally.
And since it's a software package that can be spun up in a VM or a mech or even an appliance, which is even harder, in the Wi-Fi world, there's at least over the last few years before controllerless Wi-Fi has become much more popular. But I always had to figure out, where is my traffic going? Where do I want it to go? Which VLAN do I need it on? And what controller am I putting where? And so I always had this mentality of, I have this stack of controllers, where am I going to put them? Okay, there's 2 here, there's 2 over here, there's 3 over here, and so on. And I'm building that network out, but I'm building it out with hardware that happens to be running set software. And I think the difference here is that I'm spinning up these network compute resources wherever I want them and however I need them.
And that makes perfect sense. So the next on my list is to try it out myself, because we've been talking about Celona over 3 episodes now, and I'm still extremely curious to just have a feeling for it, to feel how it works, how it looks like, how to configure. It's like, you have this this gut feeling, this first impression about the sleekness of a product. Some products, they're very cumbersome and difficult to deal with, and buggy and ugly, and some of them, they're super sleek and modern and nice. I hope that Celona, it falls into the second category, and I would really love to try it out. So will we be able to try it out anytime soon where we live in the UK?
So I do know that there are test deployments in the UK with private cellular, and I'm just not sure where the UK is in its full commercial release of whatever frequency is going to be used for this private cellular. I do think that there are some test networks that are using what's called band 42, which is a little bit of a different frequency range than the CBRS band 48. But I'm not sure what the UK is going to actually approve for commercial use. And I don't think that. Well, I will say this: in the United States, there was before CBRS was approved for commercial use, there was a process where you could ask for a test license. And you were going to say, you basically filled out a form that said, I'm going to test from this date to this date using this equipment on this frequency range, and they would give you a temporary approval to do so. And I don't know if something like that exists in the UK, but I think what you'd really be looking for is the commercial release, the commercial availability of a frequency within the UK that would allow for private cellular.
Fingers crossed, mate. Stays there always ahead in terms of CBRS and the frequencies that you are allowed to use in private cellular, not only CBRS that we know is just a frequency. And right. With Wi-Fi 6E, you have more than us. I'm jealous a little bit. Mm-hmm. And I think that concludes the stuff that I have on my list. Do you guys have anything else to add? Matt, any more questions about Celona in this episode?
I think that's covered everything on the list. Brian, anything else from you?
No, I'm sure you guys have a lot of editing to do.
You'll be...
Not the case. I think we've smashed amazingly professionally. It's going to be a beautiful episode. So in this case, Brian, thank you very much for your time. But before we close this episode, if someone has more questions, technical questions about the Celona operation and would like to reach out to you, where can they find you?
Perfect. Me specifically, or just in general, Celona?
Oh, you specifically, of course, because Celona, I know it's Google.
Yeah, Brian, Brian, at celona.io.
Okay. So guys, reach out to Brian if you have any more questions. And thank you very much for listening or watching. This episode is going to be released in both audio and video. And we will see you back next week or in 2 weeks' time.
Cheers, guys.
Thanks.
Thanks.